the title may be a little misleading. I'm not going to spend as much time talking about particularly the growing pigs as I had originally intended to, and we're going to focus more on the heat stress. But if you have questions, you can ask me. You can interrupt me. I'm very comfortable being interrupted along the way. So when we think, why did we get into heat stress at all? Heat stress is a big problem. It's a big issue for the industry, and the citation that's cited most often, it says it costs the U.S. swine industry $300 million a year. But that reference is over 10 years old. So what I did in this figure is I just took the price per bushel of corn and soybeans in 2003 when that was published, through 2013, which was the last year that they were in the database that I took that from, to show you the price of corn has doubled to the extent, and beans, to the extent that feed is 70% of the cost of raising pigs. Seasonality probably costs substantially more than $300 million. The second line, seasonality costs me more than PERS, was a quote that Steve Pullman made. He was the director of Western Operations for for Smithfield. So he oversaw about 600,000 sows. And so in his system, and he gave this at a scientific conference, and really that helped put the stimulus towards some of the funding agencies that heat stress actually is a big deal, and some funding has gone toward some of this work. Okay. So today we're going to focus, I think, exclusively on the female, unless I forgot to take out the male slides. There are effects on the male, and they're measurable, and most of them are dealt with because of artificial insemination. In screening the ejaculates, we get rid of most of the reproductive problems. There's some cost issues because we keep more boars around because of higher discard rates in the summer. But at least as far as on the actual fertility, most of the seasonality of the male is taken away. So what is the impact of heat stress? And so I've listed these kind of in chronological order, if you will. For the breeding herd, first, puberty tends to be delayed. And if you actually look at the age of puberty of your gilts, you'll likely find it's older for those maturing in July and August and September than any other time of the year. When they do begin to cycle, they tend to express estrus weaker, and they're more likely to show irregular cycles, also shorter cycles, so not necessarily 21 days. Once we get them mated, if they go through heat stress early in gestation, we have higher embryo mortality. So that's part of the contribution to increased return rate, also reduced litter size. If it happens late in gestation, we've got fully formed pigs, we've got a sow with an elevated body temperature, she can't cope with it, increased fetal mortality, we have increased stillborn rates. The increased abortions and sows that are not in pigs, so they tested positive for pregnancy, but when we went to move them to the farrowing house, they were not pregnant. Okay? And they were pregnant at some time. We see this decreased lactation feed intake because of undergoing the stress, and we'll talk a little bit about that. And so that has impacts on subsequent reproduction. Longer weaned estrus, smaller ovulation rate, lower subsequent litter sizes. There is an increase in sow mortality. I'll show you a figure. There's not enough room, but we could keep going. And you guys have seen all these things. And then this is, again, focusing on the sow. Okay, so this is the mortality graph. This is USDA data that Steve Meyer put into a graph. So national data, sow mortality rate 7 or 8%, except in July and August when it jumps up to 10 or 12%. Okay, and it happens mostly around farrowing. If we look at the amount of time that sows are in and around the farrowing versus gestation, incredible disproportionate mortalities in farrowing, and it has to do with the metabolic heat stress that's associated with that phase of production. This figure is pregnancy rate. So it's real-time ultrasound pregnancy rate at 28 days. Okay, and there's 56 farms. And the middle line is the average of those 56 farms. So they ran 85 or 90%. In the summertime, they dipped down to 75 or 80%. And then these were all in the same database, and so they divided them. They just said those with the highest pregnancy rate and those with the lowest. So half and half. You see the lowest ran 80 to 85, which at this time, this is back from 2001 data. So at that time, 85% wasn't terrible, but dripping down to 65 made our annuals really bad. But their highest ones were 95 and above. and dipped clear down to 90%, which today might be a dip for several of us. In 2000, there weren't too many folks for whom that was a dip. The biggest difference between the farms on the top and the bottom. Anybody want to guess what the biggest difference was? The buildings were built from the same blueprints and the identical design. Every farm. They were within a geographic region we could drive from one farm to the other in 45 minutes. Anybody else? The feed came from the same feed mill. Semen came from the same stud. They had different people. Okay, so the take home of this, the quickest, not the easiest, the quickest way to get rid of seasonality of reproduction is to do everything right every day. And if you do that, we can really minimize the impact of seasonality. Okay, it's easier said than done. So we know that it's really tough to do everything right every day, and so we said let's try to find ways that are maybe a little bit easier than that. So we got some funding, USDA funding, and we said we're going to do some heat stress work. So we went. These are 4 barns in Missouri, from Saline County to Boone County, and this is their daily temperature cycles over a 2-week period. And this was either end of July or beginning of August. And you can see this is degrees centigrade, but it doesn't matter. Kind of 24 to 26 down to 21. And then up here, and we got some variation. But 28 to 31, this 31, is a non-cool celled barn. The others all had cool cells. Okay? And you can tell those cool cells functioned somewhat better in some barns than the others. These weren't all built at the same time. The intent of us collecting this was to say, what happens on real farms? So if we're interested in studying heat stress, we don't want to mimic something that's so outlandish that it would never happen commercially. Okay? So these are Missouri farms. So that's what we chose as our temperature cycle in our heat stress work. And so we have environmental chambers on the campus where we can put sows in and we can control the temperature and we can control the cycle of those temperatures. Okay? So it cooled down at night, heated up, was hot for the middle of the day, and then cooled back down. Of course, if you're going to study heat stress, you have to have a control group, and rather than look at another season of the year, we can put them right next to each other in a chamber that's identical, except for a temperature pattern that's within the thermal neutral zone of the sow all the time. Okay? So that's a picture of our chambers, and this is what it looks like inside when we set up with gestation stalls. And so these are 2 feet long, 2 feet wide, and 8 feet long. I know most stalls aren't 8 feet long. That's what our equipment worked, and I didn't think that would have too big of an impact. We were able to fit 6 farrowing crates in each. So we had a hot chamber for gestation and a hot chamber for farrowing and a thermoneutral for each. Okay? And so what we did is the sows were in thermoneutral for the 2 weeks before farrowing, for farrowing, and for 10 days after. Or they were in heat stress for all 3, or they were in thermoneutral. So think of the gestation barn for thermoneutral or heat stress, and they switched. Okay? So at this point, we were looking at the effects of heat stress on lactating sows and looking a little bit before and after with the idea of when would you really try to moderate it. And this is respiration rate. So the pigs cool themselves. If they're outside behaviorally, they'll look for shade, they'll look for wallows. Or pigs are inside, they can't do that. So they breathe faster. They shunt blood to the skin to try to get more cooling. And they drink more. That's about what they can do. So we measured respiration rate, and we have armies of students that help us with projects like this. And this is the respiration rate. So these pigs appeared to be thermoneutral. They were breathing about 25 breaths per minute. The heat stressed ones breathed about 45 breaths per minute, late gestation. Okay? When they moved to the hot chambers, and remember half of them went from here to here and half from here to here, those are pretty similar. And then similarly post-weaning. Okay? So the heat stress was indeed a stress. They were having to change what they did to cope with this. Okay? Did it work? These are rectal temperatures. So back here, these weren't significantly different. Okay? So that increased respiration rate, at least statistically, kept them from having an elevated body temperature. In here, these were different. And so when they got into hot chamber in lactation, their body temperature went up. They could not breathe fast enough. And especially if they had not been preconditioned to that heat in advance. Okay? The other thing you notice, these go from 38.3 to 39.4. So a full degree centigrade different, and these thermoneutral ones are thermoneutral. So this is their new body temperature. Okay? So did they have a fever? No. The heat associated with milk production elevates body temperature. A full degree centigrade. Okay? We know that parity 1 females are more susceptible to heat than older sows. Why? Because they're still growing. So they've got the heat of milk production and the heat of growth. So they tend to suffer more. And if you go back to your production records, you'll find that parity 1s have a bigger difference of weaned estrus in the summer versus winter than older parity females. So we wanted to see if that increase in core body temperature was true across parities, because everything in our chambers was gilts. And so we went out to the farm, and this is done at our farm, and we went out and we jacked up the heat in the farrowing rooms for a couple of farrowing groups and just measured temperatures. And indeed, whether you were old or young, when you went into farrowing, your body temperature went up. Okay? It's the thermoneutral or hot, your core body temperature you expect to go up. Okay? So now back to our chambers, parity 1 females. We measured feed intake. So these are limit fed, as you would in gestation. We dropped back down to maintenance a couple days before farrowing. And this is day of the trial. They all farrowed within a 3-day window, but this is the average of 24 or 36 sows per line, something like that. And you can see that they go up. We were trying to feed them ad lib. And what you see is these thermoneutral ones went up more. And if they'd been in heat stress prior to the thermoneutral environment, actually a little bit more, so maybe a little bit of compensatory. Yeah, that wasn't statistically different. And then we put them back on, we weaned them and put them back, followed them out. Okay? So if we just look at the lactation period, because the other times we were controlling feed intake. During lactation, they were on full feed by hand, but as close as we could get to full feed. And so again, this is set now, not day of the trial, but day of farrowing. So day 0 is the day they farrowed. You can see they all went up. But again, our thermoneutral pigs ate more. Okay? So you would expect that, I think. I hope. Did it matter? Well, if we measure energy balance, so we said this many pigs, this much growth, this much feed intake, what does it take? What we see is that only that one group was a good part of lactation was above energy balance. So the others were losing energy. Okay? If they're in a catabolic state through lactation, they're more likely to have a prolonged weaned estrus interval. Okay? This is piglet weights at birth. They were identical. At 10 days, these ones that were always thermoneutral were a little bit higher, but at weaning, these were significant differences. Okay? So we didn't measure milk production, but these pigs didn't have anything except milk and whatever they stole out of the lactation feeder. So I would suggest that thermoneutral sows ate more and produced more milk. Okay? So I said already, sows increase respiration rate, they shunt blood to the skin, and they drink more. And if that doesn't work, rectal temperature goes up. Okay? And there's negative implications on that on production. If we think about the hormones involved with that and energy metabolism, we should be able to measure some of these. We'd expect a decrease in IGF, which would result in a decreased follicular growth. So we're going to have, again, prolonged weaned estrus. We might have inferior oocyte qualities. This is the next phase of our studies. Okay, so now we're looking at these in gestation, and we kind of answered, we thought, some of the questions, at least in lactation. Jamie helped with some of these. And so this is weeks of gestation, animals that were hot or thermal neutral, and this is respiration rate. So early on, and we ramped up, temperature started being ramped up at 2 weeks after breeding. And you see respiration rate just kept going up. Thermoneutral ones didn't. Rectal temperatures, they deviated. Okay? So even with increased respiration rate, under that summer environment that we recreated in our chambers, they were not able to cope and maintain the rectal temperature that we would expect them to, okay? Or that their bodies wanted to. There were some differences in insulin and glucose. So we're into the energy metabolism. I'm not going to go into more of that, okay? But we can measure it more detailed. Because I do want to focus on the impacts that we took beyond the sows. Okay? We've studied a lot about the sows over the years. We've not done much of anything on what happens to the fetuses. So if I show you that the rectal temperature is higher in those heat-stressed sows, even though they're trying to compensate, that means these fetuses develop in a different environment. And the question is, are they different? So we have our sows that were thermoneutral and sows that were heat-stressed. Okay? And then what we did in these series of experiments, and these, I don't have her name, but Brittany Lynch was an intern, and she collected a lot of this with Jamie's supervision, and we had her walking around after weaned pigs a lot. But we took these weaned pigs, and so they farrowed in thermoneutral farrowing, and then at weaning they were weaned together. They were commingled in the same pens in a wean finish barn. Okay? And that's what I'm going to focus on for the next series. I would tell you we did 4 of these groups. The first 3 went to Iowa State. And so we did the sow work, they did the growing pig work. And if we look at all of their data, they would tell you that rectal temperature on piglets whose mothers were heat-stressed while they were fetuses was higher. So whether thermoneutral or heat-stressed environment, if you were a heat-stressed fetus, and they would tend to say it's about 1/3 of a degree centigrade higher. Okay? I'll tell you, we didn't see that in the studies we did. They see that these thermoneutral ones grew more protein and less fat. Okay? So some of the differences that we see in body composition, and we can also think about feed efficiency and energy metabolism and how those might be different depending on the environment our sows are in. Okay? So we kept the 4th group at Mizzou. Okay? And that's what I'm going to talk about is our 4th group. I'm going to show you some Barrow data. I'm going to show you some gilt data. So at weaning, they were separated by sex. Gilts were in a different room than Barrows. Okay. This is weights of these pigs, whether they're thermoneutral heat stress from birth, 24 hours at processing, which was before day 3, when they were a week old, 2 weeks old, and at weaning. We didn't see any differences in these at all. Okay. Not necessarily surprising, but we wanted to measure that. These Barrows were in, I think they had 20 head per pen in real conventional sort of wean finish for the first phase, and then after, when that would have been the nursery phase over, they moved half of them to a different facility. So these were 50-pound pigs, more or less, and they were individually housed, and that allowed us to quantify feed intake differently. And so in this case, if you're gestational heat stress or gestational thermoneutral, I'm not sure what happened to my column here, it disappeared, but it doesn't matter because this is what's interesting, is this feed disappearance is greater for piglets who were heat stressed as fetuses than those that were thermoneutral. Okay? So they ate more. So if you can think of it, if they were gestated in July, they ate more than if they had been gestated in December. Okay? That was what we were trying to target. Okay? The Barrows then, they took 40 of these Barrows individually housed and followed a lot of carcass stuff. And I'll tell you, so the expectation was that they would grow differently. Brian Wiegand is a meat scientist in our group, and he said, I think I can compensate for these differences in muscling that you're seeing, that Iowa State's seeing with some of these pigs. And so we're going to feed them with different lysine levels, and we're going to play with paline. And I'm not going to talk at all about these because they did more or less what you'd expect them to do. Between the heat stress and thermoneutral, they saw a little bit greater muscling in the heat-stressed Barrows. And there are sufficient numbers here that Dr. Wiegand believes that is absolutely biologically real and completely opposite of what Iowa State showed. Okay? So the only thing else different is our genetics. Okay? These are all maternal cross Barrows. The Iowa State pigs were all maternal F1, made it to a Duroc boar. Okay? We were following up reproduction on these, so we mated that maternal F1 female back to a different maternal line. Okay? So that's different than the Iowa State pigs. There were differences in things like color. So this is the 6-point color scale. These are statistically different, 2.1 versus 2.35, but it's like going from here to here. Imperceptible to the consumer, within the same scores as far as value. And so on the MU pigs, I'm not going to talk about the Iowa State pigs, they found bigger differences. And at some point we need to get these all incorporated together, but at least from our barrows, we didn't see differences in carcasses. Okay, the differences that were there were, they're normal. They're real. Are they important? Perhaps, perhaps not. Muscle fibers, muscle samples have been taken, and they're doing muscle fiber typing in these pigs to see if there's differences that would result in differences in meat eating quality. Okay? I'm going to talk now more about the female side. And we kept these gilts, 20 per pen. Treatments were combined. Conventional wean finish barn, 80 head rooms. Okay, so small, but the same equipment, the same heating and cooling and whatnot that we'd expect. So from 2 to 4 months of age, we took these gilts, and at least twice a week, we went out and took a lot of measures. 6 a.m. and 2 p.m., took temperatures, rectal temperature. So the intern followed them around in the pen for 165 pigs, twice a day, twice a week. Okay, and then she had a laser thermometer take skin temperatures of the rump, the shoulder, and the ear. Not the shoulder, the ear and the rump. Okay. She tried to record respiration rate as well, and respiration rate in pigs walking around pens is a challenge. Okay. But they were together, so I don't think we're biased in any way. Also put cameras in these rooms and had 24-hour surveillance. And she went back then and looked at behavior of these pigs. So each of them was marked. They painted numbers on them. So they knew each pig within the pen. And they said, was that pig standing, lying, standing at the feeder, standing at the water, or sitting? And they marked that down, and then we went back and analyzed the percentage of time that a pig was doing this, or the percentage of pigs that were doing that at any given time. Okay? So we did it at the top of the hour for 2 weeks or 6, no, for that whole time, I think for 2 months. Weighed them every 3 weeks. Okay? So this is Brittany's data. So she did this. This is sorted by barn temperature. So it's not entirely the duration of the trial. Okay? It was hotter at the end, but some of these days are mixed in. What these other lines are, this is breaths per minute, respiration rate. I think these are, this one in particular, I think because we had different people recording when she left. And so we were recording for a different amount of time, but I think we did some funky math. And it looks odd, but what's really interesting, it doesn't matter, because the treatments were recorded and calculated the same. And so the difference between the treatments is still the same. Okay. Then these are skin temperatures, and this is rectal temperature. And so it looked like, they were pretty steady. The only ones that I broke out by treatment were respiration rates, because we didn't see that difference in rectal temperature. And I told you, Iowa State had 3 replicates of these pigs, and every time they looked, they saw a difference with gestational heat stress pigs had an elevated body temperature. In the pigs that we had here, we didn't see that. And I'm reporting our pigs. Okay? We did see this difference in respiration rate, though. And it looked like as the barn temperatures got higher, the thermoneutral pigs didn't cope as well. Okay? They had to breathe faster. They were able to maintain their body temperature. Right? The rectal temperatures didn't change. That's a straight line. Okay? But they had to work harder at it. So what does that mean? I don't know. Maybe they would behave differently. So what about behavior? This is percentage of time standing by hour of the day, and this is the average over the duration of time that was evaluated. So top of the hour, 24 hours a day, so midnight through 11:59 or whatever. And these 2 treatments. So it looked like the pigs stood a little bit more early in the morning. They kind of laid down and stood up again in the evening. Not considerably different, not statistically different per treatments. Numerically, you can see the red lines on top more often than the blue line. This is the percentage of time they were standing at the feeder. These were statistically different. They were pinned together, so we don't have individual feed intake. We don't have feed intake by treatment even, okay, because they're commingled. But if I say these pigs 14% of the time were at the feeder and these pigs 9% of the time, I would wager there were differences in feed intake. Okay. And so did they grow faster? Not at all. Identical growth. Okay. So they ate more and didn't grow more. Okay. I thought I had the Barrow data in here, and I don't. I don't know why. I do have individual feed intake on the Barrows. They're brothers. They were individually housed. The heat-stressed Barrows did eat more than the thermoneutral Barrows. Remember, they're housed in the same room now. This is gestation. This is about day 14 of pregnancy till day 110 of pregnancy. Farrowed together, weaned together, grown together. Okay? So again, if I tell you their brothers ate more and these ones stood at the feeder more, I think I've got very good circumstantial evidence that the gilts as well had higher feed consumption without any concomitant increase in growth. Okay? We were really intrigued to follow reproduction as well. And so we looked at these gilts, and when the oldest gilt was 150 days old, we started daily heat detection. And we used a full physical contact with a boar for 15 minutes a day. They were young boars, and they didn't quite do what we wanted them to do as far as stimulation. They weren't as sexually aggressive as we wanted them to be. One went lame, we got another one, but he was also a young boar. So only 6 of the 123 gilts showed heat within 40 days. Okay? And I've only once in my professional career had that low of a percentage of gilts express puberty with boar exposure. Okay? It's unfortunate. This was in the summer, but I showed you the performance growth and stuff was okay for maternal line gilts. So we said, well, at that point, let's give them a shot of PG600. 81 of the 117 responded within 5 days or 7 days. Within 5 days, and showed induced puberty. Okay? So I don't think it's that they were incapable. We shipped all of them down to Suffolk, Virginia, to the Tidewater Agriculture Research and Extension Center of Virginia Tech. And they were collaborating with us. They had farrowing capacity. From a biosecurity standpoint, once they went to anywhere, they couldn't go to any of our barns that had farrowing capacity. So Mark said he would farrow them out. This is the distribution of PG600, and looks like my other columns don't show up. If they did, I could tell you. Well, they do on here. They're blue on here, and they're not different. Okay, statistically not different. So the heat response was essentially the same. It was poor, but essentially the same. So at Tidewater, these gilts were group housed. They started heat detection with and artificially inseminated them to York boars. They limit fed them in gestation, very conventional sort of management with group gestation. They put them on ad-lib feeding with twice-a-day hand feeding and lactation. They tried to not foster unless they were at extremes, and then only within treatment. The farm was PERS negative, seropositive for mycoplasma ileitis, but they hadn't seen any clinical signs. I was actually down in Virginia 2 weeks ago, and the manager of the farm says, "I love your pigs. They just lay down and farrow babies." And so I don't know what their other genetics are, but they were very happy with them. So we just break out some production measures. And so the thought was, if they ate more, didn't grow anymore, what sort of a pig are they? Okay? And were they different? So gestation length was the same. The weight at breeding is a management thing, the same. Gestation weight gain, the same. Lactation weight loss, numerically different, not statistically different. But numerically, at least, these heat stressed, again, this heat stress now was 250 days ago. But numerically, at least, they lost a little bit more weight. Tended to have eaten more feed. Okay? And so I'll tell you there's 4 replicates that they farrowed in. And I presented this first when 3 replicates were done, and this was statistically different. The 4th replicate was exactly the opposite of the first 3 in the the order of the difference. And so it brought them closer together. But if this was 0.05, we would say it was statistically different. And so 0.07 is still a pretty strong trend with 57 or 63 litters or something like that. So reasonably small numbers. I believe that biologically this is real. Okay. This is piglet numbers per litter. And it really stinks that if you look at it on here, you can see this light blue line that shows up as nothing there. Whoops. But it's the same. It's the same pattern. So total number born is right here. It's a little bit above in both. Okay. Again, not statistically different. Number born alive, higher for, again, not statistically. Stillborns and mummies, not different. Number weaned, and this is again with 3 replicates. So the combination of a numerically more born and numerically less dying with 3 farrowing groups led to a statistical benefit in number weaned for the gestationally thermoneutral housed as fetuses, sows, when they were having their first litter. When we add the 4th group, the statistical significance goes away. Okay. If I go back and forth, you can see the one on the left goes down, the one on the right goes up, all because of, I think, 12 gilts that were very different than the others. Okay. But they're part of the group. P.22, that's not very strong. Okay. And pre-weaning survival, 0.08 difference. With the limited number of litters we've got. These were all fair at the same time, in the same rooms, the same management, same health. I would suggest that this is probably real. Okay. And so we know that there's direct effects of heat stress on pregnant pigs. The effects on those pigs is, I'd say, beginning to be better understood. Okay, some of the energy balance stuff. We need to pursue some more of the hormonal analyses and really try to figure out when are the intervention times and what should those interventions be if it's not cooling. Okay. Some of those effects leading to increased rectal temperature of the sow, and rectal temperature then intrauterine temperature. And if she's shunting blood to the skin, perhaps reduced uterine blood flow. And the impacts on those fetuses is real. Okay. And probably results in a reduction of feed efficiency, may or may not have effects on carcass. I think some real differences in reproductive performance that make our estimates of the impact of seasonality very low compared to what the true costs are. Okay, so if our replacement gilts are gestated in a hot mother, we're going to be dealing with these feed efficiency issues for every pig that they ever have. Is the implication. Okay. Now, again, our data right now is all out of first parity sows. Those sows are laying down for their second litters, I think, starting the end of this month in Virginia Tech. Okay. So Michelle Rhodes is at Virginia Tech, one of the scientists there, and she's actually a dairy person, originally from down around Jeff City somewhere. Shelley Bodie. You knew Shelley? And so she's taking these pigs and she's taking milk samples and she's looking at milk production, milk composition, and seeing what they get there. We've got a proposal into pork board right now with some much more intense data collection. So instead of letting them farrow out, we're going to breed a bunch of them and kill them and be able to collect a lot of other tissues at specific points in pregnancy. And so we get a more refined measure of what those effects are. We think we need to pursue these endocrine profiles by parity. We're starting to know what our parity ones are. I'm certain our multipara sounds are different, okay? And that needs to be characterized.